So the quadratic formula, I'm not sure, again, like I said, if you remember it or not, if you even got it. So this x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Does that sound familiar to you guys at all? Yeah? Okay. But again, I don't know to what extent they actually went over this last year. So for prior knowledge, I want you guys to evaluate each expression using order of operations. So for order of operations, remember that's PEMDAS. Please excuse my dear Aunt Sally. So first you want to do anything inside the parentheses. Then you want to do anything in the exponent. And then you multiply, divide, add, and subtract in that order, okay? So you do parentheses and exponents, and then any multiplication and division and any addition and subtraction goes at the end, okay? So if I look at the first example, I see I have exponents here. So 5 squared gives me 25. And then I have that minus 4 times 1 times negative 2. So I did the exponents first, and then I need to do multiplication and division. So I'm going to do this part here. So I got 25. That's negative 4 times 1 gives you negative 4. And negative 4 times negative 2 is going to give us a positive 8. And then the last thing I do is addition. So 25 plus 8 is going to give us 33. So for my final answer, I get 33. Okay? So I want you guys to go ahead and try number 2 and number 3. I wasn't recording. So for the skill today, we have the quadratic formula. And it says, given the quadratic equation, ax squared plus bx plus c equals 0, you're going to find the solutions using the formula. And our formula is right here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then this right here, b squared minus 4ac, that's called the discriminant. So whatever's underneath the square root is called the discriminant. And I want to add a note here for you guys. If the discriminant is negative, you will get 2 imaginary zeros. Okay. And that comes from basically taking the square root of a negative. You cannot have a square root of a negative. So, let's say for my formula, I end up getting like negative 5 plus or minus the square root of like negative 12 all over 2. I cannot have a square root of a negative. This is going to give you 2 imaginary zeros because of this negative right here. You cannot take the square root of a negative, okay? You can't take a square root of a negative. That's going to give you 2 imaginary zeros. And so for the purpose of this class, we are not going to be doing any imaginary examples. But I just want you to know that in case if it shows up on like the SBAC or something, you know that if it's a square root of a negative, it's going to be imaginary. And so we have no real zeros for that, okay? But again, for the purpose of this class, we're not going to see any examples like that. I just want you to know in case if you ever do see it, that means we have no real zeros. They're going to be imaginary. All right, and so then that brings us to our steps. So the steps to find the zeros using the quadratic formula is to first change the function notation f of x to 0. And then you need to identify your a, b, and c once you have your A, B, and C, you're going to substitute into the quadratic formula, and then you need to calculate and simplify the solutions. So if we look at our first example, this is already on your paper, so you don't have to copy it down. But the directions say show your work clearly and completely. Find the zeros of each polynomial function using the quadratic formula. You need to give exact solution in simplest form. And then you need to tell me whether the solutions are rational, irrational, or imaginary. But again, for the purpose of this class, we're not going to be looking at any imaginary values, okay? So for number 1, we have 2x squared plus x minus 6. And so the formula we have is ax squared plus bx plus c. And so I need to figure out what are a, b, and c. So the a value is always going to be in front of the x squared. So my a value is going to be 2. Then my b value is always in front of the x. And so there's nothing in front of it. Remember, that's implied to be a 1. So b is 1. And then our c is going to be at the end. C is going to be negative 6. Okay? So if I start my, I'm going to rewrite the formula just so you can see. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, so I'm color coordinating for you so you can see where everything gets plugged in. Very important though right here, this is the opposite of b, so it's a negative b. So if b is positive, it becomes negative. If b is negative, it becomes positive. Okay, it's the opposite of b, and then you kind of just go plug in the rest of it. Okay, so I'm going to plug in, I got x is equal to the opposite of b. My b is positive, so I change it to negative 1 plus or minus the square root of my b, which is 1. So 1 squared minus 4 times a, which is 2, times c, which is negative 6, all over 2 times a, which is 2. That's everything plugged into the formula. And then we have to basically just simplify, okay? So just like I had you guys do, I want you to plug this whole thing into the calculator, how it shows up. So on a calculator, you're going to open a parenthesis, then you're going to put 1, close the parenthesis, then do x squared, then do minus 4, parenthesis 2, parenthesis, negative 6, close the parenthesis, okay? So everywhere you see a parenthesis, put a parenthesis, and then the negative, for like the negative 6, you want to use the negative symbol underneath the 3. So negative 6, close the parenthesis, and press equals. Okay, and I want everybody to practice using the calculator. So go plug this whole thing into the calculator and see what you get for your answer. Okay, lefties, tell your partner what did you get for your answer right here. All right, were you guys all able to get 49? Yes? Okay. If you didn't, you need to let me know so I can come around and see how you plugged it into the calculator. But make sure everywhere you see a parenthesis, put a parenthesis. And then the negative symbol, you want to use the one underneath the 3. Okay? All right, so then we need to simplify here. X is going to equal -1 plus or minus. Look at your multiplication chart. Does 49 show up on your perfect squares? We got 1 and 4, 9 is 16, 25, 36, 49, 64, and so forth, right? 49 is on the list. So what's the square root of 49? 7 over 4. And then we look at this plus minus right here. The plus minus means you have one that's negative and one that's positive. So I have to split that into 2. I'm running out of room there, so I'm just gonna continue this over here. I have x is equal to -1. I like to do the subtraction one first just because it's going to be the smaller one. So -1 minus 7 over 4. And that's going to simplify to -1 minus 7 is -8 over 4. That's going to give us -2. And then I have the other one that's positive. So x is equal to -1 plus 7 over 4 equals 7 minus 1 gives you 6 over 4. And that's a fraction, so we can simplify by 2. That's going to give us 3 halves. Positive 3 halves and a -2. So for your final answer, you're going to say the zeros are -2 and a 3 halves. And neither of those have square roots, or those are both called rational zeros. Okay. So again, you first want to find A, B, and C. Once you have your A, B, and C, we're going to plug them into the formula. And then you're going to simplify as much as possible. When you get to this step, you can just put that whole thing in the calculator and see what you get. And then remember, you want to check for perfect squares. If it's a perfect square, you want to simplify it. And then this plus minus means you have one that's subtraction and one that's addition. And simplify as much as possible. Okay? All right, so let's go ahead and try another example together. Again, we're not always going to have a perfect square like we have in the last 3 examples. That's not always going to happen. So let's see an example where it doesn't simplify. So go ahead and copy number 4 on your paper. We got 5x squared minus 3x minus 1. 5x squared minus 3x minus 1. All right, so we still do the same thing. Go ahead and write it to your partner. What are A, B, and C? Okay, on a count of 3, everybody tell me what's A. Ready? Tell me in 3, 2, 1. Thank you. B, tell me in 3, 2, 1. Good, it's negative. And C, tell me in 3, 2, 1. -1. Awesome. All right, so let's go ahead and plug that in. So x is equal to the opposite of b. So what's the opposite of a -3? +3. And then I do plus or minus the square root of b squared. So b is -3 squared minus 4 times a is 5 times c is -1 all over 2 times a, which is 5. And then here is where you grab the calculator. 3 plus or minus the square root. So again, plug this in the calculator. Everywhere you see a parenthesis, you put a parenthesis. And then if it's a negative, you do not want to use the subtraction sign. You want to use the negative, which is underneath the 3 on the calculator. Use the negative symbol times 3 squared is the x squared button. And everywhere you see a parenthesis, put a parenthesis. The negatives, use the negative under the 3 instead of the subtraction symbol. Okay, and lefties, double check with your partner. What did you get under the square root? All right, on a count of 3, can I have everybody tell me what did you get for under the square root? Ready? Tell me in 3, 2, 1. 29. Okay, good. This is 29, and 2 times 5 is 10 in the denominator. All right, then just simplified. But notice, now I'm going to check for root 29. Is root 29 on your perfect squares? Remember the perfect squares? Let me write them down in case if you don't remember. That's 1, 4, 9, 16, 25, 36. 29 is not on the list. Do any of these numbers go into 29? Let's see. 36 is too big. 25 times 2 is 50. 16 times 2 is 32. 9 times 2 is 18. Times 3 is 27. And 4 doesn't go into it. So none of those go into 29. So I can't really simplify the root 29 anymore. So the last thing you need to do is basically split this into your two answers. So for my 2 zeros, I'm going to have x is equal to 3 minus the square root of 29 over 10. And the other one is the plus. So 3 plus the square root of 29 over 10. And then both of those have square roots. So are they rational or irrational? Irrational because they have a square root. So irrational because they have a square root. So that's your final answer there. Okay, so you're not always going to have a perfect square right here. You might end up with something that does not simplify, so you just split it into the 2 zeros, one with the minus and one with the plus. Okay, so I want you guys to go ahead and try this example now. For number 5, we got 2x squared minus x minus 4. Okay, so you should have had 1 plus or minus root 33 over 4. And then remember to split that into one positive and one negative. I normally do the negative first just because it's going to be like the smaller value. So x is going to equal 1 minus the square root of 33 over 4. And then you need the other one, it's going to be 1 plus the square root of 33 over 4. And then both of those have square roots, so what are those called? Irrational. Okay, good. And that's your final answer. All right. What time is the bell rings at? 31, right? All right, so I'm not going to do another example.